All right, this is a video for Algebra 2. This is Unit 1, Section 3, and these are word problems, okay? So our objectives today is to create equations to solve a variety of word problems such as mixture, time distance, rate, and work problems, okay? I'm going to do one of each. I'm going to do a mixture problem, I'll do a time distance problem, and then a work problem, okay? The other thing we need to do is, when we solve word problems, we have to interpret the solutions in context. We have to know what those numbers mean, okay? So there are a number of, problem-solving strategies. This is the one that's being offered to you guys today. This process that we've got here is, first of all, we have the question, all right? You have to read the question. And if you're like me, and if you're a terrible reader that reads it and then goes, okay, I didn't comprehend a single word that I just read, you may have to reread, okay? That's a normal process, okay? But when you have that question, skim the problem, find the question, okay? Figure out what you're trying to find, and then restate the question in your own words, okay? Sometimes how they write it is just a bunch of crappy math jargon, and it sucks. But, reword it, see if it makes sense, okay? Read the question again, okay? Identify keywords and numbers, all right? And find your clues, all right? This is important to find your clues, okay? And we'll kind of go over that. And then your strategy, or as I like to call it, strategery. Define your variables, write an equation, and select a solution method, all right? You may want to read this a couple times, all right? All right, the other thing, problem-solving strategy. Okay, we are going to use tables for a lot of these problems. All right, and I'm going to show you how that works. But we've got three types. We've got mixture problems, work problems, and distance, rate, time problems. Okay, so the first one is this one. Okay, it says, how many gallons of pure water should be evaporated from 160 gallons of a solution containing 12% of salt so that the remaining solution contains 20% of salt? Ugh. How many of you have a bright idea right now how to do this problem? Just after reading it once?
You gotta get 12% of 160 gallons.
That's a good idea. Well, yeah, we will.
Only pure water, right? And so 32% of it is not water. So 100% minus 32%, and then you get how much percent is water.
All right.
And then
All right. So hold on. Let's think about something here. Okay. I'm going to draw a quick little picture here. I'm going to draw a cylinder.
Oh wait, no.
Okay. And here's water. Okay. Currently, there is 12% of salt. Okay? Now, if you leave water in a bucket, what's going to happen to that water? It's going to evaporate. Water will evaporate out. Okay? The question is how much water, how much H2O needs to leave to get 20%. So we're trying to figure out how much water needs to leave. We have a 12% concentrated solution of salt. So in that salt water, 12% of it is salt. The other is water. How much water needs to evaporate in order to get 20%? Okay, that's kind of what's going on. Okay, I like to draw pictures. That's what makes me happy, all right? So, the question says, how many gallons of pure water should be evaporated? So, that's the question. How many gallons of pure water should be evaporated?
8%, right? Of 160.
The question, okay, hold on. You're right, hold on, let me talk. How many gallons? Okay, so let's define a variable here. Okay, I'm going to say this. X is equal to the number of gallons. We don't know what that is. This is what we're trying to find. Okay, so what we need to do is we need to create a table. Okay, all these problems kind of help out with our tables, or we have to use a table to solve these problems. So what I want you to do is draw this table here. I'm going to want you to draw a line here, 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 and here. Okay? This is the amount of salt, okay, in that part. And this is the total solution, okay? And up here in this box, we're going to write the original amount. So original amount, okay? This section we're going to call removed. And in this one, we're going to call this the new amount. Okay? This is pretty much your standard mixture table that you'll use. Okay?
And the one says remaining? Or
Removed. This one says removed. This one says new amount. Okay. So in the total solution, let's figure out what we need to put here. Okay, how many gallons of solution did we have?
160.
160 gallons of a solution. All right. So I'm going to put 160 gallons. Okay. Now, it said that 12% of that was what was in there already. Okay. And you did the right thing. You were like, well, we need to find 12% of 160. So if you do that, that's just going to give you, I'm going to do all this math up here. I'm going to do 0.12, 12% times 160, and that gives you 19.2. That's gallons. So you actually have, in that 160 gallons of water, 12% of that is water, or is salt. So you have 19.2 gallons of salt in there, okay? So in this box, we're going to put 19.2. That's the amount, that's gallons of salt. Okay? Now, we have to think about this for a second. When we evaporate water out of this, okay, when water evaporates, well, percent of what?
The salt and the water. Well, not really the water.
Well, but yeah, you're right. You're right. Here's my question. How much?
When the water leaves, if 10 gallons leave, that would be completely different percent of salt because it would be 150.
Right,
And
but
if you're still doing 12%, you'd have to change.
but here's my question. How much salt leaves when water evaporates? Zero. So here's the thing. You have to ask these questions, and that's the hard part, is asking these questions and figuring out what goes where. So in this thing of okay, well, what's been removed? What amount of salt has been removed from this? Zero. Okay? Zero amount of salt has been removed. But now the question is, how much water has been removed?
How much do we need to, or how much has been?
How much has been? Do we know?
We don't.
What do we know is the amount of gallons to be removed. So let me write this. Number of gallons of water, of H2O, removed. Well, how much? We haven't done the problem yet. So how much water has been removed?
19.2.
X. That's what we don't know. That's what we're trying to answer here. Is how many gallons of pure water should be evaporated. That's how much has been removed. We don't know. So if we don't know what that number is, well, I'm going to put an X. Okay? And so to get that new amount, what you have to do is you have to say this. Well, I'm going to subtract the original amount by what's been removed. So I get 19.2 minus 0. Okay? And then here, to get you have 160 and then you remove out the x, that your new amount is going to be 160 minus x.
Would you just equal those together?
No, because we want to get, our goal, let me do this. Our goal is 20%. Okay? So, hold on. Let's think about this for a second. We have 20% is the same as 20 out of 100. Right? Now, we want this to equal, okay?
Oh, is this a proportion?
It's a proportion, yeah. We want it to equal the new amount, which is 19.2, over what's been removed, the new amount, 160 minus x. And that's the equation we got to set up. That's the hard part.
I already know the answer.
You should get what, 64 for x?
Yeah.
Yeah. So if you solve this, all right, and that's how we do this, okay? Because, and let's think about this for a second, all right? If I take the amount of salt over the total solution, this part right here is the part to a whole. Okay? These questions are hard. Okay, they are very hard, all right? But let's go ahead and do some algebra and solve this out. Okay, hopefully you have enough room. You may not. That's okay. I'm going to cross multiply here when I have a proportion. Cross multiply.
You need to distribute 20 times.
Because this is a quantity.
Yeah.
Good question. Yeah, so I'm going to do 20 times 160 minus x, and that's equal to 100 times 19.2. Okay. So 20 times 160, what is that? 3,200? 2 times 16 is 32. Keep the zeros, 2 zeros. Okay, minus 20x, and that's equal to, what is that, 1,920? Okay, help me out, guys, if I subtract 3,200 from both sides. We get negative 20x is equal to, this gives us negative 1,280. And if I divide this by negative 20 and divide by negative 20, then we get that x is equal to positive 64. All right? That's what we
60 gallons, 64 gallons of water left?
right. Well, not left.
No, that's gone,
That's been removed, exactly. So then you have to sit here and you have to go, okay, 64 gallons of H2O is removed. Okay? So you have to put this into context. The numbers represent things. They mean things. Okay? Kind of tricky, kind of weird. All right, now the next one I find a little bit easier. Okay? These rate problems. Okay? And so we have Celeste rides her bike to work. Okay? She averages 12 miles per hour. Okay? On her way home, she travels 8 miles per hour. If the total trip takes 1 hour, how far does she live from her work? Now, I do want to tell you guys, or show you guys, that we do have an equation here. That distance is equal to the rate at which you travel times the time. Okay? And so that's a pretty standard equation. You'll see that pop up over and over and over again.
D equals, what is that? What is that?
D is equal, distance is equal to the rate at which you travel times the time. Okay? Now, if I were to do this, okay, I'm going to rewrite this equation again. All right? You can figure out, if you've got D is equal to RT, all right, if you were to solve this equation for, say, time, all right, and if I divide by R and divide by R, the R's divide out, and you're left with that time is equal to the distance at which you travel, or the distance you've traveled divided by how fast you travel. All right. So when you have that, now let's go back over here. Let's kind of read this and fill out the table. All right. It says that Celeste rides her bike to work. Okay. That's the first trip. Okay. Trip 1 is going to work. Okay. And we don't know that distance x. Okay. We don't know how far that is, all right? But we do know that she travels a certain rate during that time. She travels at a rate of 12 miles per hour. So I'm going to put that rate here, 12, okay? All right, on the second trip, that's the trip going home. That's to home, okay? Again, we don't know that distance because we want to know how far does she live from her work. Okay, x, okay? So x equals the distance to work. Okay, to and from work. Now, when she went home, how fast was she traveling? 8 miles per hour. That's this value here. Now, it says the total trip takes 1 hour. No. The total trip takes 1 hour, all right? The time, we don't know how long it takes to go to and from. It doesn't tell us that. However, we have this equation that tells us what time is. Time is the distance divided by the rate, okay? So if I come back over here, I have a value for distance, and I have a value for rate. So the time at which it takes me is going to be x divided by 12. However far it was, divided by 12 miles an hour, gives you the time. Same thing for the second trip. Okay, I can take the distance and divide it by the rate, and it gives me x over 8. All right? Now here's the hard part, is putting it all together. And then saying, okay, the trip takes a total of 1 hour. If I add both of these times together,
You get 2x over 20.
not yet. If I take the total trip is 1 hour. So that means the time there took a certain amount of time, the time back took a certain amount of time. If you add them together, what do you get? 60 minutes or 1 hour. Okay? So if I do this, if I take x over 12 plus x over 8, that's going to give me 1 hour. That's the hard part, is coming up with that. This is created. That takes practice. This is the hard part right here, is writing that. Okay? Now, if we add fractions together, we've got to come up with a common denominator. All right? The common denominator, I'm trying to think, is going to be 24. So I need to multiply the top and bottom over here by 2 and 2. 2 times 12 gives me 24. 3 times what gives me 24? That's going to be 3. So multiply the top and bottom by 3. So as a result, I get this. I get 2x over 24 plus 3x over 24 is equal to 1. Okay? Now, if I have a common denominator, I can combine my numerators, leave my denominator, so I get 2x plus 3x all over 24 is equal to 1. Okay, combine what you have in your numerator. 2x and 3x together gives you 5x divided by 24 is equal to 1. Ugh. Okay, solving this for x is kind of tricky. But what I do is I multiply both sides by 24. Okay, if I'm dividing by 24, the opposite is multiplying by 24. These divide out, and we get that 5x is equal to positive 24. Divide by 5 and divide by 5. So I end up getting that x is equal to 24 fifths. Okay, you don't normally say that number, so if you actually do the division, you get that x is equal to 4.8. But 4.8 what? What was x?
Distance.
What was the unit? Miles. Okay. 4.8 miles. Uh-huh. Okay. Kind of hard, kind of tricky. Okay. Okay, the last problem that we have is a work problem. All right. So let's go ahead and read this. It says, a student can type a 32-page term paper in 3 hours. Okay. The student has a friend that could type the same paper in 2 hours. Now, if they work together, how long would it take them to type the paper? So let's identify the question. The question is, how long would it take the two of them to type the paper? All right, so we're trying to find a measure of time. Okay, so we're trying to find the time. So t, let's have that be the time to complete the paper, the 32-page paper.
Can you just do another proportion since they have like a
We will.
constant?
All right, but we want to make a table. When you see that you have these work problems, then we want to make a table here. All right, so we've got this. We've got the two people, we've got the student, and we've got the friend. Okay, and we have the rate at which that they can type. Okay, and then we have the time that it takes, and then we have this other one that says the fraction of the job completed. So the fraction of job completed. Okay, so what we know is that it takes the first student 3 hours. Now what I do is I'm going to write that it's 1/3. Okay,
What did it say, fraction of what?
fraction of job completed. Okay, and then it takes the friend 2 hours. So I'm going to do 1/2. So you always have to do the reciprocal. All right, so we want to, here for these rates, we want to flip the fraction. Okay. Now, the next column is the time that it takes. Now, we don't know how much time it takes. That's what the question is asking us, for both of them to do it. So I'm going to put t there, I'm going to put t there. All right. In the next column, we have the fraction of the job that's completed. So in order for us to figure this out, okay, we've got this. We've got, I'm going to do 1/3 times the time. So it takes them 3 hours times the time that it takes. Okay, and then here I'm going to do 1/2 times t. Okay, so you're just going to multiply these two together to get the amount of job that's completed. Now here's the hard part, is coming up with an equation now. What I'm going to do is I'm going to take 1/3 t, I'm going to add that to 1/2 t, and that's going to equal 1 term paper. Okay? So I'm going to dissect this real quick. This portion, these two portions right here, is the this is the amount of paper typed, that's typed. Okay, and this is the whole term paper. Okay, that's what those mean. Now, you can get a common denominator here. Anybody have another idea how to get rid of the fractions?
Do the reciprocal?
I don't want to do reciprocal.
Do we get a decimal?
No, don't want decimal.
I don't know, you multiply it.
I can multiply the whole thing by the common denominator, which would be 6 in this case. Okay? So if I took 6 times 1/3 t plus 6 times 1/2 t is equal to 6 times 1. So 6 times 1/3 is actually going to give me 2t. And then 6 times a half is going to give me 3t. That's going to give me a total of 6. Okay? I can combine our like terms, so 2t plus 3t gives me 5t, and that's equal to 6. Okay? I'm going to divide both sides by 5 and by 5, and that's going to give me a value of that t is equal to 6/5. Now, I don't really like that number, but if we put that into a decimal, then we get that time is equal to 1.2 hours. Okay? So we would say that it would take them 1.2 hours, both of them working together, to type that paper.
I thought it was gonna be 1 hour.
And the thing of it is you kind of have, this is one of those problems. This is one of those problems, guys, where you're like, all right, when am I going to have to ever use this in the real world? Well, if you sit there, and it's more of like just kind of understanding how the numbers work. But if you sat there and you said, hey, my neighbor wants me to paint their house. I can paint this many square feet in an hour. Maybe if I enlist a friend, we can get the job done faster. I wonder how long it would take us. If they can paint fast and I can paint fast, 2 people working on the same job will make it go faster. And this is where they do that. And actually, a lot of companies will budget, a certain amount of hours for a certain job, and they use this same kind of idea.